Dear students, let us learn one important chapter from grade 11th, that is redox reactions. In this video, we will be learning only introductory part about redox reactions. In chemistry, there are different types of reactions which are occurring in our day-to-day life. You all know. But among all, redox reaction is one of the most important reactions which are very common and very usual in day-to-day life. Example of redox reactions are corrosion of metal is one of the famous example of redox reaction. Respiration is one of the famous example of redox reaction. Working of battery, combustion, and there are many more which involves the basic concept of redox reactions in them. So let us learn what is all about redox reactions. You know very well the term redox is the fusion of two things. One is a reduction and the other is oxidation. Alright? Classically, you can understand these two reactions on the ground of three main fundamental definitions. The first definition is gain of oxygen is oxidation, wherein the opposite to gain, loss of oxygen, is said to be reduction. Oxidation and reduction, these two things are opposite to each other. So whatever happens in oxidation, the reverse is true for reduction. So in oxidation, we understand gain of oxygen. In reduction, we allow loss of oxygen. I can take the basic example for this is, if I take carbon and if I allow carbon to be burnt in the air, it is a combustion reaction, but obviously it will give CO2. You can see carbon has undergone oxidation. Very simple. Now, in the sense of reduction, I can say if I take the example of MnO, alright, and if I add carbon in it, what I can say, let's take familiar example of zinc oxide, which is practical example, and if I find this reaction to allow, I will simply get Zn plus CO. Here I can say zinc is oxidized and I can say ZnO is reduced. This was the simplest concept from which we have started learning redox reaction. Now, more to this, there are two more definitions which are essential to understand in gaining better knowledge of redox reaction. Second definition says that loss of hydrogen is oxidation and opposite to loss, that is gain of hydrogen, is a reduction. What I am telling you, loss of hydrogen is oxidation and gain of hydrogen is a reduction. Now let's make this thing clear with the help of example. If I take CH4 and if I burn CH4, I will find, it may be pyrolysis, I can write C plus 2H2. Alright, what I have found? I have found that CH4 have lost hydrogen and it has turned itself into carbon. This can be the well example of, I would say, oxidation. Now on the basis of the same ground, I can take one more example for the sake of gain of hydrogen, wherein I can write H2 plus O2, it forms H2O. For the sake of balancing, I write half over here. This I can say our oxygen have undergone reduction. Alright, so here I can say I find gain of hydrogen, here I find loss of hydrogen. So this is one of the second definitions. Now, the third and the most familiar for the chemistry of grade 11th and 12th is in terms of electron transfer process, according to which it is said that loss of electron is oxidation and opposite to loss is gain of electron is said to be reduction. The best example I can quote over here is, if I take zinc and if I allow zinc to lose electron, it will turn Zn2 plus with the loss of 2 electron. So here I can say this is an oxidation reaction, and opposite to this, if I take Cu2 plus and if I add 2 electron in it, I will say it becomes Cu. So there we find gain of electron. So on the basis of transfer of electron, loss of electron is oxidation and gain of electron is a reduction. So let us summarize this for one more time. The concept of redox reaction is most familiar among all kind of reactions in chemistry. Hence, its study is important. In general, redox is a fusion of reduction and oxidation, which are opposite processes to each other. In learning oxidation, you can learn three definitions. The first is gain of oxygen is oxidation, loss of hydrogen is oxidation, and the modern term loss of electron is also oxidation. In reduction, you can see opposite things. Loss of oxygen is reduction, gain of hydrogen is reduction, and gain of electron is also reduction. I just want to highlight one thing in the end of this video is when there causes loss of electron, the valency of the element increases. Remember this trick. The valency of this zinc is 0. The numerical charge present on the element is called its valency. So charge on this stable element is 0. It is moving towards +2. This seems that I can say valency of the element increases. Alright, and you can find the reverse trend. It was 2+ before, now it has become 0. So I would say valency of the electron decreases. So when there observes increase in valency, it is an oxidation. When there is a decrease in valency, it is a reduction. So in this way, we can keep the definitions and basics of redox reactions in mind very properly. Thank you so much. Thank you for watching.